design and manufacture of an industrial TEC chiller for sale in the market. Hey everyone, welcome back to another video in my Peltier cooling series. This time, I'm going to show you how to build a professional-grade Peltier chiller, one that's solid enough to turn into a real business. You could even set up a small workshop, make these, and sell them for a profit. After I built this prototype for my company, we ended up selling over 500 units in just 1 year. In a test to find out the cooling capacity of this chiller, without putting a temperature controller on this chiller, I let the water freeze. As you can see, all the water froze. The calculations show the cooling efficiency of this system at best 37%. First, I will explain the design idea of this Peltier chiller using SolidWorks software. There is a water housing in the middle. Water enters from one side and exits from the other. Peltiers are placed on the top and bottom surfaces of this water housing. Large aluminum heatsinks are placed on the Peltiers, and the heatsinks are cooled by a fan. One thing about the housing design is that when water enters it, it forms a very thin and wide layer and passes under the cold surface of the Peltier. In this way, the majority of the water particles are cooled by the Peltier. The middle water housing is sealed with a large O-ring, aluminum lids, and pan head screws. Another thing is that the thickness of the aluminum under the Peltier is only 0.5 mm because I wanted the water to be cooled faster by the Peltier. Then, the Peltiers are assembled on the lids in special places with silicone paste. Finally, large aluminum heat sinks are placed on the Peltiers and the two heat sinks are screwed together at the top and bottom with long screws. You can insulate all the middle parts with foam spray or refrigerator insulation foams. By making a frame and placing two 12 by 12 cm high-speed fans, the main core of this Peltier chiller is ready. All the parts were sent to the CNC milling workshop, and then I assembled them in the workshop. In the prototype, I made the aluminum heat sink by assembling aluminum blades in the grooves of the base plate. This is time-consuming and unprofessional, but it is enough for the design of the prototype. In the industrially made samples, aluminum heat sinks that are made with the skived heatsink manufacturing process were ordered, which is a one-piece heat sink with higher working efficiency. The assembly was done in the same order as described, and the prototype was ready for testing. The cooling efficiency was about 30% for this sample, which was increased to 37% in the industrial sample with an integrated aluminum heatsink. In this image, you can see the final industrial sample ready for sale to the market undergoing quality control tests, which has brought 2 liters of water from a temperature of 25 degrees to a temperature of 2.5 degrees. Finally, by installing a PID temperature control module, the water temperature can be controlled at a constant temperature required for different devices. For example, here I connected 3 of these chillers in series for this laser device and kept the water temperature constant at 22 degrees with a PID temperature control module. These Peltier chillers are mostly used when the temperature of a device needs to be controlled with high accuracy, for example, 0.05 degrees Celsius, or in compact systems that require a chiller with not very high cooling capacity. These chillers have a longer life, higher temperature accuracy, and no need to replace the refrigerant gas compared to chillers with compressors. I really hope you found this video helpful, especially if you're thinking about building your own Peltier chiller. I'd love for you to join the family. Just hit that subscribe button if you haven't already. And your likes? They honestly mean the world and make all the hard work over the past 6 months feel totally worth it. Thanks so much for watching, and I wish you all great health and success.